Hello and welcome to applying the cast rule. So in the last video you went through and we talked about how to calculate cast rule, and we looked for the values in the particular quadrants. So today I can apply the cast rule to equations involving trig equations or trig functions and solve all the values of theta. So we're looking at angles between 0 and 360 now. So I've got a couple of examples to run through here in this particular video. So let's start off with our first set of examples. We're just jumping straight in here. So 6 cos theta equals 3 root 3. I'm setting them up similar to the questions that you're going to see in the homework. So the first thing is you want to solve for cos theta. So maybe I'm going to insert this in here. So steps, first step, isolate the trig function. So the first thing I'm going to do then is I'm going to get cos theta by itself. In order to do that, and divide by 6. Now, the homework uses 3 root 3, etc., etc. I just want you to go ahead and use the calculator and simplify it down. All right, we don't need to worry about exact value in this course, other than the section we had already. So I'm not incorporating it together with the equations. So you just go ahead, 3 root 3. So you end up calculating that to what it's actually worth, and we get 0.866. Okay, so 3 decimal places is lots. To solve this then, we need to use the cast rule, because what we're going to find is that there is 2 particular values where there's an answer. So here's my cast rule, and you're going to be writing this for every question, a little cast rule. In what quadrants is cos theta positive? So what quadrants? And the answer to that one, quadrant 1, all functions are positive there. Quadrant 2, cos is positive down there. So we're going to get 2 angles. We are going to get an angle right here, which is theta, and that's going to be the first angle, so theta 1. The second one is going to be in this quadrant, and it's going to be measured just like that. Okay, so now we go to the calculator, and we actually calculate cos inverse of 0.866. So we go back to the calculator, and the calculator is only going to give you one possible answer here. So 0.866 cos inverse, I get 30 degrees. All right, so theta is going to equal 30 degrees. Now the calculator only gave us one answer, and we know from the cast rule that there's 2. So you ask yourself, where's 30 degrees? Well, 30 degrees is in quadrant 1. So that means I have theta 1. So underneath I'm just going to write that's theta 1. So the question is, what is theta 2? Well, the angle, the calculator will always give you an angle with the x-axis. Okay? So that means that if this angle right there, that I just did in red, and I'll emphasize it again, if that angle's 30, guess what? That angle is also going to be 30 degrees. Okay, we have symmetry with the x-axis. It's like a mirror reflection. So that would mean, and I'll do it down below, theta 2 will equal a whole cycle going all the way around. So it starts at 0, you end at 360 if you go all the way around. All right, so all the way around is 360. So that means that 360 minus 30 degrees. So I'm going to take away that little amount, and I get 330. Okay, so that means that theta 2 is 330 degrees. So if you type in cos 30 and then you type in cos of 330, what you'll find is you get the exact same value. So there's actually 2 solutions for every ratio. So 0.866 has 2 possible solutions. All right. So there we go. That's it. You're looking for 2 possible solutions. Sometimes there's 1, and sometimes there's more. So we'll talk about that as we go. All right, so for question number 2, isolate the trig function. So I'm going to subtract 4 from both sides. So that would mean sine theta would equal 6 take away 4 is 2. So then the next thing we do, we're going to use our cast rule to figure out where sine's positive. There's going to be a couple people here maybe that are thinking, well, I already know the answer, and that's fine. So cast rule, 2 is positive, okay? So this value is positive. So what two quadrants is sine positive? Everyone's positive here, and sine is positive there. So that means I'm going to have the quadrant here, one angle. The quadrant here, I'm going to have a second angle. All right. Now, next step is to do the calculator. Theta equals sine inverse of 2. And when you do this with the calculator, you're going to find the calculator gives you an error. Okay. Now we can't write error as our answer. Okay. Error here. The reason for it. Okay. What it is that no angle exists. For sine inverse of the value 2. Here's the y. Okay. Sine theta is opposite over hypotenuse. So if sine theta equals 2, sine theta equals 2, that would mean that, therefore, opposite divided by hypotenuse was equal to 2. And if we do some multiplication here, multiply both sides by h, the hypotenuse, so we'd have inverse. My opposite is 2 times my hypotenuse. So that means, therefore, the opposite side is greater than hypotenuse. And you know that in a right angle triangle, that's not possible. Okay? Right angle triangle, the hypotenuse is always the longest side. All right? Always longest. So that's why there's an error for sine and cosine greater than 2. Now tan can be greater than 1, but sine and cosine can't be greater than 1. Okay? So keep that in mind as we move through here. All right? Next example. Negative cos theta equals 0. So we could divide both sides by -1 technically here. It's not really going to change anything other than the sign. So that means that cos theta is still equal to 0. Now, if we draw our cast rule here, cos is 0 degrees. So when is cos 0 degrees? So this is another unique one. So I'm going to put a star here. So the second example is a unique example. And the third one, this is another unique one. It's kind of an oddball one. All right. So when is cos theta equal to 0? So a bit of a side story here. So for an angle theta, I'm going to flip that triangle the other direction, like that. Right angle, theta. So if we label our sides, opposite, hypotenuse, and adjacent. So when is the adjacent, because the hypotenuse is never ever going to be 0. When will the adjacent be 0? So the question is, basically, when will this length here be decreased to 0? So if we go back to the cast rule, that occurs when I have a line straight up and down. Okay, so at this point, hypotenuse is equal to the opposite. All right. And if I go the other direction, straight down, hypotenuse is equal to opposite. All right. If we're looking at the other sides, here, the hypotenuse equals the adjacent, which is not what we want. We want the adjacent to be 0. And here, hypotenuse equals adjacent as well. So I'll just put it in brackets underneath. Adjacent equals 0. Adjacent equals 0. So there's the two angles. First one's 90 degrees. And the second angle, when you go all the way around, it's also a right angle, and it's at 270 degrees. All right. So examples 2 and 3 are unique cases. Number 4, this is kind of like the homework in the book. The problem is the book, again, I don't know. I wish they didn't do this. What I'd say, first of all, let's calculate that. All right. So you need to just use the calculator. 3 take away root 3 equals divided by 3 equals So I'm just going to say this is just simply 4.423 equals 1 plus tan theta. All right. Now isolate for tan. So just do that with your in the book. All right. Just go ahead and get rid of the exact value. Use your calculator. Subtract 1. So that tells me that tan theta is equal to negative 0.577. All right. So the next step is draw your cast rule. Okay. Where will my answers be? So this time, tan is negative. So what quadrants is tan positive? Well, everyone's positive there. Everyone's positive there. Or sorry, not everyone. Tan is positive there. So that means tan is negative in this quadrant and in this quadrant. So that means my answer will be, there's going to be 1 here. That's theta 1. And then my other angle is going to be down here. So there's theta 2. So there's where my 2 quadrants are going to be. So one answer is going to be between 90 and 180. My other answer is going to be between 270 and 360. So if we go ahead and use the calculator, so theta equals tan inverse negative 0.577. We find that theta equals, or according to the calculator, so 0.577 negative, shift tan, is negative 30 degrees. All right, negative 30 degrees is not a possible answer because I said already my 2 answers, it's got to be between 90 and 180 or between 270 and 360. Negative angles means that you're rotating in the opposite direction. So that means from here to here is 30 degrees. Okay? So what that tells me, though, is that I can find theta 2. So that 30 degrees, we can find theta 2 now because theta 2 is 360 degrees minus the 30. So all the way around and then back up to 30. So we know that theta 2 is 330 degrees. Okay, so there's one possible solution. Now I said from symmetry, if the arm is 30 degrees away from the one x-axis, it's going to be 30 degrees from the other x-axis. So how do I figure out theta 1? Well, if I go all the way to this, the x-axis, I've gone the 180 degrees, but I got to back up 30. So it's going to be 180 minus 30. So that means 150 degrees. And there are my 2 solutions. So I end up with theta equals 150 degrees. And my theta 2 is 330 degrees. Okay. I'll cut this video off here, and then I'm going to come back, and we're going to do 2 more examples, and then I'll let you get going on the homework.